You go to a stationery shop to buy pens, and the shopkeeper says that a packet of 5 pens costs 22 rupees. That means the cost of each pen is 22 by 5 rupees. Can we represent this quantity using any whole number or any natural number? No, right? Can we represent this using any integer? Integers are 0, 1, 2, 3 and so on, -1, -2, -3 and so on. We cannot represent 22 by 5 in any natural number or a whole number or any integer. We can represent this quantity in fractional form. Let's take one more example. We have a table where timings of the day are given and the temperature recorded at that time is listed. Now let's look at the change in temperature per hour. From 10 a.m. to 12 noon, the temperature changed from 11 degrees Celsius to 14 degrees Celsius. So the temperature per hour will be 14 degrees Celsius minus 11 degrees Celsius divided by 2 because 2 hours have passed. So this is going to be 3 by 2 degrees Celsius per hour. Let's look at the change in temperature from 12 to 3 p.m. So that's once again 3 by 3, which is 1 degree Celsius per hour. Lastly, let's look at the change in temperature from 3 p.m. to 7 p.m. That is 10 degrees Celsius minus 17 degrees Celsius divided by 4. 4 hours have passed. That's minus 7 by 4 degrees Celsius per hour. Now, these numbers, 3 by 2, 1, minus 7 by 4, these numbers include both positive fractional numbers and negative fractional numbers. So these can be represented in the form of P by Q, where Q is not equal to 0 and P can be positive or negative. Here 1 can be listed as 1 by 1, right? So all of these numbers can be written in the form of P by Q. Let us see some more such numbers. We have 3 by 4, 7 by 9, minus 10 by 17, 3 by minus 2, 2013 by 2014. Now, the numbers which are expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0, Q can be any number other than 0, are called rational numbers. So basically numbers which have a numerator and a denominator. The numerator can be positive or negative. The denominator can be any number other than 0, are called rational numbers. These are represented by capital Q and they are also called quotient numbers. We can express any natural number in P by Q form also. For example, we have 5 and we can write it as 5 by 1 or 10 by 2, which simplifies to 5, or 15 by 3, which simplifies to 5 again. Similarly, we can also express the whole number 0 as a rational number. 0 by 1, 0 by 2, 0 by 3. We can also express an integer in P by Q form. For example, minus 3 can be written as minus 3 by 1 minus 6 by 2. So what we conclude over here is that all the above P by Q forms, they are all rational numbers. So we see that all natural numbers, all whole numbers, and all integers are rational numbers. Now let us look at this collection of numbers and categorize them into these boxes. First of all, we have 1. 1 is a natural number, an integer, a whole number, and also a rational number because we can write it as 1 by 1 in the P by Q form. Then we have 1 by 2. It's not a natural number, not a whole number, not an integer, but a rational number. -2. That's an integer and a rational number because all integers are rational numbers, right? Then we have 0.5, which is actually 5 by 10 and simplified to 1 by 2, which is again a rational number. Then we have a mixed fraction, 4 1 by 2. So this is 2 into 4, 8 plus 1, 9. 9 by 2, which is also a rational number. -33 by 7 is again a rational number. 0, it is a whole number, an integer, and a rational number. 4 by 7 is a rational number. 22, it's a natural number, a whole number, an integer, and a rational number.